This Zoom session is being brought to you by the Fractal Bullseye Bubble Water. All right, yes. We're finally doing trigonometry, which literally means triangle measuring. And we'll start off with the simplest type, right angle trigonometry, measuring a right angle triangle like this. With an angle gamma of 90 degrees, two angles alpha and beta, which add up to 90 degrees, so each one is 90 degrees minus the other. Sides A, B, and C. That's 5 numbers, 6 numbers, but we've specified gamma. And the idea is that if we specify 2 of those 5 numbers, we usually can specify the other 3. All right. Not with if you just specify alpha and beta, first of all, they have to add up to 90 degrees. And A, B, and C could be any size. You could take a triangle with given alpha, beta, and gamma, and then just expand or contract it. But the ratios would be constant. So, okay, given a triangle like this, then, okay, first of all, like I say, the angles alpha and beta are complementary when at 90 degrees minus the other. And then the sides are in various trigonometric proportions. A over C is sine of alpha and cosine of beta. B over C is cosine of alpha and sine of beta. A over B is tangent of alpha. B over A is tangent of beta. So these can use, and therefore we get various formulas. A equals C sine alpha and C cosine beta. A equals B tangent alpha and B over tangent beta. B equals C cosine alpha and C sine beta. B equals A over tan alpha, A over tan beta. C equals A over sine alpha and A over cosine beta. C equals B over cosine alpha and B over sine beta. And this is the right triangle. A squared plus B squared equals C squared. Therefore, C equals root of A squared plus B squared. A equals root of C squared minus B squared. And B equals root of C squared minus A squared. Also, alpha and beta are arctangents of A over B and B over A. So, like I say, given 2 of those numbers, alpha, beta, A, B, and C, you can usually get the other 3. And so, for example, here we have a right triangle where we're given alpha of 35 degrees and B at 12.1. What's beta, what's A, what's C? Okay. The first one, the easy one, is beta. It's the complement of alpha. 90 degrees minus alpha, so that comes out to 55 degrees. That's straight. Okay, that's right away. Then, now we're given alpha and B. Generally, it's good to use these numbers, these, so to speak, the freshest data. So we can get A as B tangent alpha, 12.1 tangent 35 degrees, which comes out to about 8.47. These I write equal signs, but really to be precise, I should make them approximate equality. And B over C is cosine alpha, so C is B over cosine alpha, 12.1 over cosine 35, or 14.8 about. So those are these 3 numbers. Here, right angle triangle, we're given alpha and A. So angle and opposite side versus angle and adjacent side. Okay, alpha is 20 degrees, A is 13.7. What's B, C, and beta? Okay, as ever, the other angle is the easiest to find. 90 degrees minus alpha, which comes out to 70 degrees. All right, now, to find the other 3 numbers given alpha and A. Let's see. B equals A over tangent alpha. So that's 13.7 over tan 20 degrees, which is about 37.6. A over C equals sine alpha. So after a bit of algebra, C equals A over sine alpha. That's 13.7 over sine of 20 degrees, about 40.1. Here we're given the angle alpha, and we're given the side C. So angle and hypotenuse. What's A, B, and beta? Well, as usual, beta is easy. 90 degrees minus 42 degrees, 48 degrees. A over C equals sine alpha, so A equals C sine alpha. 17.5 sine 42 degrees, that's about 11.7. B is C cosine alpha, 17.5 cosine 42 degrees, approximately 13.0. Now here we have 2 sides, 3 and 4. What's the 2 angles? What's the hypotenuse? Okay, for this one, it's quite easy. This is the Pythagorean theorem. C equals root a squared plus b squared, root 3 squared plus 4 squared, root 25, c equals 5. Simple enough. Now tangent alpha is opposite over adjacent, 3/4. So A alpha is arctan 3/4, about 36.87 degrees. B is arctangent of 4/3, about 51.13 degrees. I could, from here, take this 90 degrees minus this and get beta and get the same result. But like I said, using A and B is using fresher data. Here we have hypotenuse and one short side. What's the other short side, and what are the two angles? Okay. All right, so B, well, okay, it's root c squared minus a squared. That's from Pythagoras. Root 3 squared minus 1 squared is root 8, which is 2 root 2. Now for alpha and beta, well, we have 1/3 is sine alpha. So alpha is arcsine of 1/3, about 19.47 degrees. For relative to beta, a over c is adjacent over hypotenuse, so cosine. So beta is arc cosine 1/3, about 70.53 degrees. Now here we're getting some trickier problems where the use of a picture actually is justified. Here are two buildings. Here's a tall building, here's a short building. The tall building is 2,001 feet tall. From the base of the short building, you look up to the top. This is called the angle of elevation. It's 35 degrees. If you ride the elevator up to the top floor and get on the roof, then the angle of elevation to the top of the other building is 15 degrees. The question is, what's the distance between the buildings and what's the height of the shorter building? Okay, this we kind of have to sleuth our way to. Starting with this over this, 2001 over D, that's opposite over adjacent of 35 degrees. So 2001 feet over D equals tangent of 35 degrees. Now, right, flipping upside down and transposing, D equals 2001 feet over tan 15 degrees, or about 57.7 feet. I suppose I calculated 0.7 and then a zillion decimal places after that, but even doing one decimal place is a little too much, but better than too many than one digit too few. We're only given accuracy to within a foot, so saying 0.7 is pushing the is maybe claiming a little more accuracy than you really deserve. All right, now we'll find h. Well, if this is height h, then so is this. Just slide across a rectangle. This side, this distance here is k, which will be 2,001 feet minus h, h being what we need. And k over d will be tangent of this 15 degrees. So tangent 15 degrees is 2,001 feet minus 8 over 2857. From here, we do some algebra. Transpose the 2857, transpose the 2001, take negatives, and get that h equals 2001 feet minus 2857.7 feet times tan 15 degrees. Okay, punch a few buttons, and you get that the height of the shorter building is 1,235.3 feet. So they're 2857.7 feet apart and 1235.3 feet high. And the other one is 12.35.3 feet high. All right. Alrighty, let's stop recording.